Good? Okay.
So next up, we have the session from Milliseconds to Insights, building a production-ready PostGIS plus CDC architecture with Apache, NiFi, and AI data cloud. Quite an interesting and mouthful topic, I would say. Looking forward to the session. Over to you, sir.
Yeah, thank you so much. Hello, everyone. So maybe like it's in the afternoon, so but I just want to start with a probably I'd stay here. So with a little lighter note, when there's a power failure in a specific area or somewhere, there's a rain or storm or something, like usually like your power goes off, your light goes off, and you keep calling your, what do you call, your electricity, local operations, and then say when it comes, and most of the times it is always engaged. Like we technically don't know when it will come back and when to fix it, right? So that's something like which actually fueled for what I'm going to show you today. It's going to be a demo filled. I don't have any slides, just have 2 or 3 contexts where you can grab the source code of this demo and other stuff that you can do with. Before I go there, I just want to give a quick introduction about myself. So I'm Kamesh, I'm a lead developer advocate at Snowflake. And I have around like 2 decades of industry experience, like working in all kind of softwares, mainly on cloud and AI, and now into data. And that is my social handles on the QR in case if you want to get connected, talk more about this thing that we are going to discuss today about PostGIS, Snowflake, anything, I'm happy to chat about that. And also like I'll post the links for the demo and videos and other stuff as part of this one as well. Okay. With that, so what I want to do is like I just want to jump into the demo. So you can scan this QR in case if you want to grab the demo sources, additional documentation, some other YouTube videos about what are all the things that I'm going to talk today, so that you don't lose it. But anyways, I'll do a LinkedIn post after this session as well. You can grab from there. And again, I'll flash it again at the end of the session, right? So I want to just start with a little thing, right? I just that's all pretty much about the slides. Let me go here and see if I'm able to load my screen. Is this big enough? Yeah, I'll just do it for 50, right? So let me see if it can grab this one. Sometimes the session would have expired. In case if that's the case, then I might need to start it again. Let's wait for the maps to load. So basically what's happening is that imagine that I'm kind of a operations manager at a specific operations unit. Let's say you're managing a smart city kind of stuff. Then I got technically you get a call on this morning, right? For example, let's go here. Let's see if I can load this data again. Go here. I'll just stop this one and start one again, just to make this faster. The usual glitch you get, you run dashboard. And I should have the dashboard running right now. Let me see if it runs, picks up stuff. So let me see if it comes up quickly. All right. 1, 2, 3, 4, loading data. So maybe it's taking a few seconds up. Let me see if I can shift to my hotspot and see if I can get it faster. Okay. It's up. All right, hope I should get it here. This again. Okay, it's all there. I'm going to do the refreshes and then I should be all good. Okay. So I'm giving it some time to load it. So, but the story is like this, right? So, what am I trying to load right now is a neighborhood thing that is there in Bangalore as a fictitious use case that I'm taking right now. So where I'm going to manage a little city within myself, so where I'm going to talk about what happens to my neighborhood when something goes wrong. That's the initial story of this, and then we will connect the story to say like how we can use AI with this to kind of give you a super insights on what you're doing right now, right? So still it is a little slow. Let me see if I'm able to get the map. because map is what is all about the story today. So excuse me about this. Let me see if I'm able to connect to my PSC call as well. If that's the case, then I need to go back and fix that one because that's the actual issue. I think my IP address has changed. Give me 1 second. I'll just quickly fix that up so that we'll get back to this. Okay. What's my IP?
Unavoidable technical difficulties, right?
It's right. It's absolutely because it's my Postgres is actually protected here, so which means that I need to go keep changing my IP address every time. I think my IP address has changed. I just did that thing this morning. I think that's what I did. So just me go back and add this to my network rules, so that like I'm able to set this up. I think this is obvious thing that happens. I was thinking that my IP address will not change, but sadly it's changed. So my ingress is blocked in Postgres. So you see this, all these IP addresses are something which has been trying this morning. Okay, so let me add this to this.
All I can say is your Postgres is much more secure than mine.
So this is, I'll talk about this as well. This is Snowflake Postgres story. I think that's a little story I'll touch upon in the evening. So I think this should be okay right now. Let me see if I can get into Postgres now. Yeah, there you go. We're all good, and sorry about this little glitch, but in a way, like it showed me how hardened is my PostgreSQL as well. So let's start with this, okay? Let's go back to my maps and then load this one. You should be pretty fast now. Okay, I think I'm getting the data. There you see. So this is what I use behind. Obviously, I use OpenStreetMap with Folium. I'm using a framework called a Streamlit. If you know about Streamlit, this is what is being used for me to get my maps done. So let me find out one little thing, right? What the very first thing I want to do is like imagine that at 3 a.m. in the morning we have a little storm thing which I told you earlier. It's the same story, but now this time I just want to go find out what's happened to these red dots you see here. Let me blow this up a little. Sorry, I'm just playing with my trackpad and then get this thing out. You see these little red dots here? We have one light. All these red dots mark your floaty thing, which means that these are not similar red dots. It's the actual sensor data that's being sent to you, and then that's being synchronized into Postgres using Snowflake. So that's the whole point that is coming there. But right now, what I all have is just a location. I don't have anything about an insight onto this. How do I basically draw an insight onto this, right? So that's what we're going to do step by step. But before we go and do the modern way using AI, the very first thing I want to show you is like how do we actually do this without AI? And everybody knows how do we do with Postgres, right? So let me go here and then show you that little thing that I have. Let me go here and show you this little query. Obviously, this is a very familiar query that we have. Obviously, I'm doing a cross-join lateral here. I'm also using the K and neighborhood operator here to find out the nearest supplier who could help me to fix this faulty bulb. But the point here is, like, so this is very normal thing for people like who are technically solvable. They are able to solve this, run this query. But imagine, as I said, I'm an operations manager who is sitting at 3 a.m. getting this one and find this faulty light on my map, and I want to take an action on this right now. For me, running this query is hard because I'm not a technical guy. So what I basically wanted to do right now is I want to talk to my data. So that's exactly what I'm going to do right now. But before that, let's also verify if this query runs as well. I'll just give you a PG query. And then I'm going to find the nearest supplier. So this obvious query, it's actually running this query on my Postgres instance and giving me all the list of my nearest suppliers that I have, the distance and everything, obviously the geospatial data. But let's take it a little further up, right? So what I'm going to do right now is just as bad, I'm going to start using agents and AI using Snowflake AI, which is called a Snowflake Cortex here. So let's find two things here. So let's, for example, I'm going to go this particular thing, which is nearest to my locality in Bangalore, is SL1039. So I'm just going to go there and ask my agent, okay, I had few queries written earlier. Just going to copy this query just for easy typing, and then let's start a new chat so that everything looks refreshed. And I'm going to ask this particular thing, right? There's an AI model running behind, as I told you. I'm going to find out the nearest supplier who can give me this bulb replacement immediately. So this is the first point of thing that I'm making my data contact. As operations manager, as anybody who is not technical, who need to take care of things, the very first thing that I'm going to do here is just to go to ask a question. I'm not writing SQL query here. So my AI agent, where the data is synchronized, is writing a SQL query for it. Like if you see here, this is a SQL query that runs behind. It's doing the same lateral join query. It's using the same operators to find out. And in fact, it has went and find out the location as well, the coordinates of this supplier. And it said this is supplier who is having this faulty light maintenance for this bulb. And he stays near this particular place. 1481 was the bulb number that we used, right? He says this is particular guy. This bulb is faulty. You can find out this location using map. Obviously, I'm using OpenStreetMap here again to kind of find the location. The drop is here. The same thing, like it also gives you the drop here as well to find out this particular person is there in 4.19 kilometers. This information is much more effective as an operations guy when I want to dealing with geospatial data. Because, for example, I don't want to run the queries again and again. I don't want somebody to sit technically behind my scenes and talk about this. Okay? This is the first part of it. This is not just this, right? It's for example, like in this case, I'm just using the nearest supplier. That could also be a question for example, I just want to go find out what all the lights. Let me find that query that I have in my doc so that I can easily type it. Let's say I want to find out an unstructured query. For example, let's say I have a messy maintenance log. I just want to go find out what is the thing that can give me safety hazards involving water and rain, because we're talking about water and rain. That's what I'm going to do. I'm just going to say find urgent safety hazards because of water and rain. So this again is going to go into your maintenance request again. So again, this part of the data, because geospatial data is going to live with few other things. As you see with Cortex Search again, which is a search tool, I'll show those tools right now in a second. So once we bring the data into AI, laying a foundation of the geospatial data, right now I'm also going to get these ones, giving all these queries, because it's not a structured query, it's not just a SQL, it's a search that's happening on an unstructured data, right? That's exactly what's happening here on the show details. If we do this, I think it's kind of found few places. And right now it also says that this is where the place, it's finding out all the places. For example, it says that these are the hazards that I have. And obviously it also gives you the location here, right? The location is technically, when it's synchronized between PostGIS and to any kind of AI data cloud, it just gets into WKT format, which means that your AI agent should be intelligent enough to decode that as your latitude and longitude to kind of go find out these places, right? This makes it super easy, because when I'm going to send some technicians right here, I'm just going to send them this right thing. Now you can send it as a trigger to your WhatsApp or any kind of SMS or any other communication mechanism that you have, so that you don't need to worry about like how do I send this person there to get it fixed, right? And it gives you a lot of other information as well, like saying, okay, how do I do this? How do I fix this? And how do I do all of this stuff? It also goes to another little extent of, for example, I can also say like, okay, this monsoon I had so many failures in this particular region, the smart city that I'm maintaining. I can also ask a question like this, like, can you help me budget? Can you estimate and budget for next monsoon? So this is again, now what happened, we have all these data with this geospatial data combined with your historical data of my city maintenance records, which also gives me information about what happened last monsoon, previous monsoon, kind of a physical forecasting. I'm going to use that data and do technically a forecasting of what's going to happen next, including what's going to be my budget. So how much is going to cost me for me to make all these fixes. So these are all super vital information, but the base is your spatial data, but it sits on top of it, like it has a connected data with it. It's going to use this data to kind of give me that information, saying, okay, what is that I'm going to do with this, kind of say what's my budget, what's my plan, how many things, which suppliers I need to go find it out, and all this information is going to come up. Technically, it's taking some time to kind of do all those analysis, and it gives you a chart. In fact, so this is my monsoon 2026 budget plan estimate. It says that I have 5,000 monitor lights. These are the risks which is there, how much the maintenance cost is going to cost you, how much the supplier is going to cost you, and all this information, which means that it is not just, we're not just using a geospatial data only for a location, but you're also tying with the other things that you technically manage within your industry, right? For example, it could be smart cities, where you can building these things. It could also be a government thing that they can take up and do it in each municipality that they have. Or it could also be other things. For this, whatever data that I generated right now, it's all fictitious. It's nothing related to Bangalore, though I used Bangalore as a thing, but it's all generated data. This is one side of things. Somebody's asking on this. Same way, you can also go back and you can also do a predictive maintenance again. So this again gives you a visual representation of the exact data that we saw right now. Okay. For example, like it says here, what's going to be a forecast for right here? It's going to be, say, 45 days. What could be a seasonal risk analysis that's going to happen here? So how many failures I'm expecting, and what's going to be my weekly summary so that I'm going to have. It's going to give you all these predicted failures. So Streamlit is a very, very, what do you call, a lightweight widget thing, kind of thing, like which you can use. You don't need to write Python code. It's a very small Python code that you need to write, but you can build some beautiful dashboards with it, just giving it the data, your data frame. For example, whatever you see here is part of that, right? It's giving you a winter, summer, what failure I'm having, what's the seasonal risk that I'm going to get across all these things, what's going to fail for me, etc., right? I can also do, as I said earlier, I can also do a monthly budget thing, giving me a tabular data, and saying like where I'm going to invest my cost here, okay? What I'm trying to do right now is that it's kind of like the whole thing is like the base is for me is a geospatial data, a location or a locality or a neighborhood, but it has a relation with multiple other things that happens within the area. So how do you actually tie those things up? At the end of the day, that's a solution that you're trying to build out so that like it's easy for everybody who's involved with this particular data, all right? So let me go back to one thing. Right now, I want to touch upon last thing on this is the actual architecture. Again, this again is there in my repository, but I want to touch upon the little architecture that I have here. I just want to show you how actually I built this one. I'll tell you about Snowflake Postgres in a second. So data basically lives in Snowflake Postgres, where I have all these base tables, your street lights, neighborhoods, maintenance, suppliers, and everybody. And then I have some enrichment tables, which gives you weather, demographics, and power grid. This is a very basic schema that I have, where I have some enrichment done to my views. So this is the data which technically lives in Postgres, right, as Postgres data. Then I created a publication basically to initiate the change data capture, or CDC in short. So I kind of did this thing and then took the data and then synchronized to Snowflake using what we call as OpenFlow. I'm going to also just, OpenFlow is nothing but Apache NiFi's enterprise version, where you can use CDC across multiple data sources, taking the data into any kind of your source and destination format. All these things are converted into raw tables. Then I created 3 different things. Like one is Cortex Search, which is the AI tool that Snowflake has. So basically Cortex Search is where you can search on unstructured data. So it doesn't need to be structured. And there is a Cortex Analyst which works on a semantic model. If you heard about semantic model, this is what Cortex Analyst does. If you see those charts and everything got generated, those are all on a SQL or using a semantic model, using a semantic search. And then I also did some forecasting thing using ML, machine learning algorithm, that was giving you the budgeting and other stuff. So once I have all these data within Snowflake or any other data, AI data cloud for that matter, it's going to do all these things pretty easily for you. But the good thing is, in this here, is like I talked about OpenFlow CDC, but if you heard about this little open source project called as PG Lake, how many of you heard about this? So this is something which Snowflake recently open sourced. So what is going to, we are going to do is like right now it's in the works and pipes, like basically I'm using a CDC to kind of synchronize this data within Snowflake Postgres. But once we have this PG Lake integrated, which is going to be in soon, once we have this, then what basically happens, there's going to be a real-time replication happening between your Postgres data onto Snowflake without you doing anything else. So which means that you don't even need OpenFlow or Apache NiFi or any kind of CDC mechanisms to get the data. The Snowflake data, this Postgres, the data that's going to reside on Snowflake Postgres is going to be, can be queried within Snowflake without any change. It could be another table, another database within Snowflake for you. This is a completely open source project. I recently also had a Docker thing done here. So if you go to the Docker folder, local dev, it shows you how it basically can run PG Lake within your own Docker containers as well. So you don't need to have Postgres right now. But what it actually does is very interesting. So I'm just going to go to this one little slide to just give you a context about what PG Lake is all about. So PG Lake allows you to connect any kind of data, for example, like a CSV, JSON, Iceberg, and Parquet, any kind of format into object storage lakehouse into Postgres. You can use Postgres natural querying to kind of query this data from anywhere. For example, the usual standard thing which you can take is if you have Iceberg tables, we can bring those Iceberg tables within Postgres using PG Lake. It's going to be super, super easy. It's going to be very fast. And also, like, it's kind of like right now, as I said, it's going to be there within Snowflake Postgres as soon as possible. Snowflake Postgres is in public preview. I'll tell you how it's easiest to create a Postgres right now. So what it basically does is, if you heard about Crunchy Data, we acquired Crunchy Data a year ago, and then the Crunchy Data now became Snowflake Postgres. So which means that whatever goodness that you had in Crunchy Data has all become inside Snowflake as part of Snowflake Postgres. The biggest thing what I can attribute here is that usually when you are running Postgres, the biggest thing that you do with extension is that I have to compile the extension, load the extension, create a new Postgres image and run it. But with Snowflake Postgres, we have done everything out of the box for you. For example, if you go to my CLI and then do the PSQL, and then if I list the extensions, you'll see that most of the extensions are already there. I did not load all these extensions. The moment you create an instance of Snowflake Postgres, you get all these extensions out of the box. We are continuously adding many extensions. PG Lake is one thing that's going to be added soon, so that you can do this kind of real-time replication without this, especially for geospatial data. So that's a big advantage of this. Everything is audited, and you also saw the security side of things. You're naturally protected because it by default asks you to do network rules. Without that, it will not even allow you to connect to the Postgres data, right? So how do I create it? It's going to be super, super easy to create a Postgres instance. I think I'll show you the documentation link. If you scroll down here, if you go to this is Snowflake's homepage, you got Postgres here, and then I just go click here and then start to create one. Let me do this one here. I need to change the role. Obviously, I need to change role to account admin, so we can create the instance for now. So you click create, give a name, instance configuration. It can be bustable, standard, high memory, whichever thing suits for you. And you can go up to 96 cores and 384 GB of memory. Okay, I don't think so, like we need this much big instance for Postgres, for sure. Okay. And then so we can create any kind of these things here, and then obviously have to tie a replication policy. We have 16, 17, and 18 right now supported. And then like you can also have turn on replication by default. By default, the user that you are going to sign up is going to have a replication specific, so which means that you can do CDC and other stuff naturally. Obviously, the network policy, that's what something which is preventing in. And if you are somebody working on a cloud and you want to do a private link between these two things, then you can also use private link. So it's just one-click buttons that's going to do this. In fact, you can go up to 65 GB of storage that you can have. I think I get it right. Okay, 650 GB if I'm not wrong. Okay, have storage right here. So which means that it's super easy for you to kind of go to up to that extent of data, right? So that's about Snowflake Postgres, which allows you to do a lot of more things. A few things I've added, I already shared with you. And I think that's pretty much I have. How to get started with this, all these demos and everything. As I said earlier, if you scan this QR code, that's going to basically take you to this document here that you see here, which is a living document that I maintain. I've also given a very zero credit, no credit card required Snowflake trial of like around like $400 that you get for a month, which you can use this to sign up so that you can try Snowflake Postgres and everything. All the demo repositories are listed here. The one that you saw right now, the Streamlit one, is Postgres Snowflake Intelligence Demo. That's where we connected both these things. Once you try up, you can try all these things that I showed you right now. So the particular repository that I showed you here has all the instructions for you to do, how to set up, how to create, how to do all the stuff. All the details are documented here, so you don't need to, even including how do you configure the Snowflake intelligence as well. So which is going to be like super easy for you to kind of get started. I think a few other things that I also added here, there are some developer guides to get started with Snowflake Postgres, geospatial stuff within Snowflake. Lastly, like if you are interested in joining Snowflake user groups wherever you are, you can just join those groups, get into Slack, ask questions about all those things, etc., etc. I have some documentation split across AIML, OpenFlow, which is Apache NiFi, and Postgres and all these stuff, and bunch of videos for you to go find out. And in fact, we also have a certification program that you can also take, which is a free certification on Coursera courses. If you want to do Snowflake, AIML, and all other stuff that you want to do, just click on that link, register yourself. It's a free course. You have to pay Coursera or whomsoever you are doing with only if you want a certification. But the content is free. All right? It has data engineering. It has all other stuff that you want to do. And that's pretty much. I have 6 more minutes left. Probably I can open the floor for questions.
Sorry. Anybody, any questions? Yeah.
So this is just a cloud service, or we can have an hosted
This
instance?
is completely on cloud, and it's supported only on 3 major cloud providers as of now, plus the Gov clouds, wherever the Gov clouds is there.
Okay, okay, thank you.
Any other questions from anyone?
All right. I think no questions. 2 things. Either I said good or I said bad. But anyways, I assume that I said good. So, but please feel free to ping me on my LinkedIn or anywhere. I'm just leaving this page once more so that if you have not grabbed the document link, you can scan and take it from there. And also, like, if you want to join me on LinkedIn, please scan this QR to join me on LinkedIn. Any questions related to the PostGIS, anything geospatial, Snowflake, I'm happy to answer them. Even if I'm not, I'm happy to kind of direct you to the respective product owners who can help you answer the questions, even in case if you want to, from a customer side, right? And thank you so much for having me in. Maybe my first time in Nasik. It's pretty good. And have the fun rest of the day and rest of the conference. Thank you.
Thank you.